Hi students, in the previous class we discussed about types of curved mirrors and as well as what is a real image and what is a virtual image. Now in this video, in this class, we will be discussing about terms related to spherical mirrors. Okay, so in the terms related to spherical mirrors, first we'll be talking about what is the meaning of a pole. Okay, what is a pole? So pole in the sense, spherical mirrors are of basically two different types. So before that, we'll be talking about initially plane mirror. Now this is a plane mirror, and this is a curved mirror. That too, this is a concave mirror, and this is another curved mirror. That too, this is a convex mirror. So what is the meaning of a pole of the mirror? The geometrical center or midpoint of the mirror is called as a pole. The geometrical center or midpoint of the mirror is called as a pole. For this is a concave mirror. So we won't find any pole to the plane mirror. Okay, plane mirror does not have any pole because it is having a flat surface. It is having a plane and a flat surface. Where in case of concave and convex mirrors are having curved surfaces, they never be having a flat surfaces. The reflecting surface is curved inwards for concave mirror. It is curved outwards for a convex mirror. Whereas a plane mirror, it is having only flat surface. There is no curved surface. Hence, we won't find pole for plane mirror. Whereas, for a concave mirror and a convex mirror, we are having a pole. What is the meaning of a pole? The geometrical center or midpoint of the mirror. Okay, this is a reflecting surface. The geometrical center or midpoint of the mirror is called pole. It is denoted by a letter P. Now for a convex mirror, this is a pole. The geometrical center, see the distance from here to here is and here to here is same. The midpoint, exact midpoint of the mirror. Okay, if I measure the distance from here to here and here to here, and the same if you consider, then this is midpoint of this particular reflecting surface of the mirror. Now this is what called as a pole. The geometrical center or midpoint of the mirror is called what? Pole. Okay, here this is a pole for a convex mirror and this is a pole here for a concave mirror, where in case of a plane mirror we won't find any pole. Understood? If they are asking the examination, can you find pole for a plane mirror, means there is no pole for the plane mirror. We won't find any pole to the plane mirror. The first term related to the spherical mirrors is a pole. There is what is a pole? The geometrical center or midpoint of the mirror is generally called as a pole. Next one is we'll be talking about center of curvature. Center of curvature. Okay. So for a plane mirror, there is no center of curvature because I told you already, plane mirror is having a flat surface. Okay, no curvature. Whereas a concave mirror is having a curved surface bent inwards. Okay, where in case of convex, we are having a reflecting surface bent outwards. So we are having some curvature here. Here we are having some curvature. Here we don't have any bent. Okay, it is a flat surface, plane and flat surface. It is a curved surface. So what is the meaning of center of curvature? In one terminology, okay, I want to explain it very clearly. Now this is a concave mirror. Now if I incident the light ray, this is incident ray if you consider. Okay, it is a reflected ray. Okay, now this is incident ray and this is reflected ray. If I say this is I1, this is R1. Incident ray, first incident ray, reflected ray, first reflected ray. Now between incident and reflected ray, we know that we are having a normal line. Okay, so normal line will be 90 degrees to the reflecting surface of any mirror. Okay, it is a normal line. Normal line. Understood? So next one, this is another incident ray and this is another reflected ray. This is, we consider I2 and this is reflected ray R2 if I consider. If I draw the normal for this, normal will be between these two rays, you know that. it is also 90 degrees to the plane reflecting surface of the concave mirror. And if you observe, the normal lines are going to meet at one particular point here. This normal line, first normal line, second normal line. For your understanding purpose, I am making as N1 and this is N2, normal 2. So these normal lines are going to meet at one particular point. And this can be called as a center of curvature. Okay, one more definition is there. But simple understanding purpose, this is a very easy definition to remember. Okay, what is the meaning of center of curvature? The point at which all the normal lines, okay, of a reflecting surface will meet. Okay, all the normals, the point at which all the normal lines will meet. Okay, generally called as a center of curvature. I will repeat. No, sir, in case of convex mirror, sir, in case of convex mirror, and how will you draw the normal, sir? Okay, now for a convex mirror, if I draw the convex mirror, it is incident ray and it is a reflected ray. You know, I said already, I explained in the previous videos, that convex mirror is a diverging mirror. This is incident ray, I1 if you consider, this is R1 reflected ray. It is going to diverge. And normal line if I draw, if I extend backward, okay, another incident ray, and this is another reflected ray. This is I2, you consider this is R2. And if I draw the normal, okay, see here the normal lines are going to meet inside the mirror. So the center of curvature for a convex mirror is within the mirror. Okay, and for concave mirror is in front of the mirror. Understood? If you observe the difference, this is center of curvature here, and here it is center of curvature. So in case of convex mirror, center of curvature is inside. Concave mirror is in front of the mirror, that is outside. Understood? So here the normal lines are going to appear to be converging. So this is center of curvature. I told the definition. What is center of curvature? Okay, center of curvature means at the point at which all the normal lines will meet, called as center of curvature. One more definition is, center of curvature is the center of sphere in which the reflecting surface is a part. Okay, center of curvature is the center of the sphere. Now this is a sphere if you consider. Now if I cut the sphere into two halves, if I remove one half, okay, this is a sphere if you consider, this is center of the sphere. Okay, now it look like a concave mirror. Okay, center of curvature is the center of the sphere in which the reflecting surface is a part of it, is called as center of curvature. Now according to textbook, 10th class Telangana textbook, okay, we are having a simple definition even like this. The center of curvature means the point at which all the normal lines are going to meet, called as center of curvature. Okay, or one more definition is, center of curvature is the center of the sphere in which the reflecting surface is a part of it, is generally called as center of curvature. It is denoted by letter C. And for a concave mirror, center of curvature is in front of the mirror. For a convex mirror, it is in the mirror, within the mirror. Okay, for a plane mirror, there is no center of curvature because we don't have any curved surfaces there. This is a flat surface for a plane mirror. So next one is, after this, we'll be having one more important term is, what is a focus? Next one is, what is a focus or focal point? What is a focus and what is a focal point? Before that, okay, we can have the discussion about principal axis also, but I will be explaining initially what is the meaning of a principal axis. Okay, next one is principal axis. Principal axis. Now, this is a curved mirror. You know well, this is a concave mirror. And I told you already, this is a pole. The geometric center of the mirror is called pole. And even now, even we identify what is a center of curvature. This is incident ray and it is reflected ray, incident ray, reflected ray. So this is I1, this is R1, this is I2 and reflected ray R2. Now if I draw the normal to this, it is the normal and it is the normal. So the normal lines are going to meet at this particular point if you consider. This is called center of curvature. Then what is the meaning of principal axis? Means the horizontal line which passes through center of curvature and the pole of the mirror is called as a principal axis. This is what called as a principal axis. The horizontal line passing through or joining the center of curvature and pole of the mirror is called principal axis. Okay, the horizontal line. Okay, I will define again. I will tell the definition again. So, what is the principal axis? The horizontal line passing through center of curvature and pole of the mirror, or okay, the horizontal line joining the center of curvature and the pole of the mirror is called as a principal axis. Okay, come on. Next one, there is no principal axis for plane mirror. Okay, there is no principal axis for plane mirror. We have principal axis only for what mirrors? Curved mirrors like concave mirror and as well as a convex mirror. Next one is radius of curvature. Radius of curvature. What is the meaning of radius of curvature? Okay, now this is a concave mirror. We are having some relation of radius of curvature with some other term. We'll be discussing later after completing focus and as well as a focal length. Okay, now first radius of curvature. This is what called as a pole. I told you already. And to locate the center of curvature, this is incident ray and it is reflected ray. This is incident ray, one more incident ray and reflected ray. This is I1, this is R1 it reflected ray, this is I2 incident ray, this is R2 reflected ray. So if I draw the normals to this and here the normal and here will be the normal, understood? So the normal lines are going to meet at this particular point which is called center of curvature. So what is the meaning of, sir? What is the meaning of radius of curvature, sir? Okay, the distance between pole of the mirror to the center of curvature is called radius of curvature. The distance between pole of the mirror, any mirror in the sense curved mirrors, that is concave mirror and convex mirror. The distance between pole of the mirror to the center of curvature is called radius of a curvature. The distance between pole to center of curvature is called radius of curvature, denoted by a letter R. Radius of curvature in the sense R. Okay, so this is what called as radius of. You won't find radius of curvature for plane mirror. Radius of curvature is present only for concave mirror and as well as convex mirror. For a concave mirror, radius of curvature is in front of the mirror. Okay, for concave mirror. For convex mirror, it is inside, within the mirror. Now, this is a reflecting surface. It is a reflecting surface. It is a reflecting surface of convex and is equal to surface. So, the radius of curvature is within the mirror. The center of curvature is in the mirror. Okay, the distance between pole of the mirror to the center of curvature is called as radius of curvature. Na? So, in case of convex mirror, radius of curvature is in the mirror. For a concave mirror, radius of curvature is in front of the mirror. For a convex mirror, the radius center of curvature is in the mirror. And for a concave mirror, center of curvature is in front of the mirror. Okay, next one is focus. Okay, or what is a focal point? All these terms are very, very important because in the coming videos, we'll be discussing about ray diagrams for the images formed by both the concave and convex mirrors. Okay, and how the reflected light rays will behave and how the images are formed. To understand that, to draw the ray diagrams without any confusion, you need to understand. You have to read these concepts thoroughly, then only you can draw the ray diagrams more easily. Now, next one is what is the meaning of focus or focal point? What is the meaning of focus or focal point? Now, if I draw, this is a concave mirror, okay, it is a coated surface, it is a reflecting surface, and we can locate the pole and pole is there, and if I draw one horizontal line passing through the pole and as even the center of curvature, if you consider this is center of curvature, okay, this is what called as principal axis. Now, if I draw an incident ray, so this is incident ray and it is reflected ray. Okay, and this is second incident ray and it is second reflected ray. Okay, this is I1, you consider this is I2 and this is R2 and reflected ray R1. Okay, now if I draw the normals to this two rays, normal line is like this and here the normal. Okay, normal line will angle will be always 90 degrees. It never be some other angle. In case of any type of mirrors, there is a plane mirror or a curved mirror like a concave mirror or a convex mirror, normals will be always, angle will be always 90 degrees only. Remember this. Okay, so in case of this particular diagram, this is incident ray, this is reflected ray, incident ray, reflected ray. If you observe, the reflected rays are going to meet at this particular point. One point is there where the reflected light rays are going to meet or converge. Okay, so this point is called as a focus. This point is called focus. What is the meaning of focus? The point at which the reflected light rays are going to converge. Converge means coming close to each other, meeting at one particular point. The point at which the reflected light rays are going to converge is called as a focus. Remember this. This focus is denoted by letter F, capital F. Remember, focus will be always with capital F. Okay, so we won't find any focus in case of plane mirror. Okay, so in case of plane mirror, no center of curvature, no pole, no focus, no radius of curvature, nothing. Okay, so in case of concave mirror, okay, the focus will be in front of the mirror. Sir, for convex mirror, sir. So for convex mirror, this is a pole. No, I already told this is center of curvature. This is incident ray. This is a reflected ray. Okay, this is incident ray. This is a reflected ray because I told you this is a divergent mirror. Okay, so normal line. Now normal line between incident and reflected, normal lines are going to meet at this particular point. And this is the incident ray I1, this is the reflected ray R1. This is incident ray I2 and reflected ray R2. Now, if I extend back for this reflected ray, okay, like this, these reflected light rays are going to meet at one particular point. Here we will find the focus. So in case of convex mirror, focus is in the mirror. For a concave mirror, focus is in front of the mirror. Okay, so what is the focus? Definition of the focus in case of convex mirror means, okay, the point at which, okay, the point at which the reflected light rays appears to be coming from, okay, the point from which the reflected light rays are going to, okay, appear to be coming from, generally called as focus for a convex mirror. Otherwise, simple definition, the point at which all the reflected light rays are going to converge is called as a focus. In case of convex, the reflected light rays appear to be coming from one particular point. Now, this is mentioned as a focus for a convex mirror. For convex mirror, focus is inside. Concave mirror is in front of the mirror. You know that. Okay. Now, next after that, what is the meaning of a focal length? The simple. What is the meaning of a focal length? So, there is no focal length for a plane mirror. There is no pole for the plane mirror. There is no center of curvature for the plane mirror. There is no radius of curvature even for the plane mirror. Now we are having is the last term related to the spherical mirrors is a focal length. Focal length. Now this is a concave mirror, and as usual this is a pole. Okay, this is a what I told already, focus. This is center of curvature because this is incident ray and reflected ray, incident ray, reflected ray. Reflected rays are going to converge. This is I1, you consider this is R1, this is I2 and this is R2. The reflected rays are going to converge at this particular point. It is what called as a focus. And the normal lines are going to meet at this particular point. This is what called as center of curvature. You know. So what is the meaning of focal length? The distance between pole of the mirror to the focus. You should always measure the focal length from the pole to the focus, not from focus to pole. It should be always pole to the focus. The distance between pole of the mirror to the focus is called as the distance from pole of the mirror to the focus is called as a focal length. Okay, distance between pole to focus. Okay, distance from pole to focus is called as a focal length. And the units are commonly centimeter. Most commonly used measurable units we are using is centimeter. Okay, if you want you can convert centimeter into meter also, no problem. Okay, focal length means the distance from pole of the mirror to the focus is called as a focal length. Okay, if you observe one common thing, the focal length will be always half of the radius of curvature. Now if I take a radius of curvature, R is equal, we are having a formula, R is equal to F. If I double the focal length, I will get radius of curvature. If I half the radius of curvature by 2 is equal to focal length. Focal length will be always half of the radius of curvature. Okay, radius of curvature will be always double the focal length. Now, if you observe, the distance from here to here is 10 centimeter if you consider, and the distance from here to here will become a 20 centimeter. R will become a 20 centimeter because double the focal length. Remember this. So these all are the terms related to both the concave and the convex mirrors. Okay, I hope you all understood my explanation related to the different terms of concave and convex mirror. Okay, if you understand, please like, comment, and subscribe. Thank you.